Hello, grade 7. This is Mrs. Lopez. Today we are working on lesson 2 in our module 2. We are going to learn how to use the number line to model the addition of integers. Again, to remind you, integer is a whole number or its opposite. So an integer can be a 10, it can be negative 5, it can be positive 100, can be negative 50, and so forth. Okay, so let's look at the real world introduction to this integer addition. Suppose you received $10 from your grandmother for your birthday. You spent $4 on snacks. Using addition only, how would you write an equation to represent this situation? Oh, well, you can think about this situation as a subtraction problem, right? You received $10, you spent 4, so 10 minus 4 is 6. However, since we are in 7th grade, we are not doing first grade problems anymore. We are doing 7th grade problems. We need to represent addition only on the number line. How would I write this equation? So I know that I need to use only a plus sign, okay, for addition. I know I received $10. Received $10 is going to be a positive number 10. I spent $4. Spent is going to be my negative number. I spent negative 4. So I'm going to add 10 and negative 4 on the number line. I don't know yet what it's going to be, but I know that I'm going to add 10 and negative 4 on the number line. So I'm going to start at 0, and just like in lesson 1, I'm going to count 10 units to the right because it's a positive number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now I'm stopping at 10 and starting at 10. I'm counting 4 units to the left since I'm adding negative number. 1, 2, 3, 4. And I ended up at 6. Okay, so 10 plus negative 4 is 6. That's how you show addition on the number line. Pretty easy, isn't it? So just think about it. 10 minus 4 is 6, and 10 plus negative 4 is 6. So just for you to think about it before we move on to harder topics, 10 minus 4 is 6, and 10 plus negative 4 is 6. We were not to use subtraction, so that does not work for us. However, we know that it's an equivalent equation. Okay, example 1, modeling addition on the number line. Complete the steps to find the sum of negative 2 plus 3 using filling in the blanks. Model the equation using straight arrows, vectors on the number line. So here comes something that we haven't done before. We are going to use straight arrows or vectors instead of this skipping or counting on. Okay, so we are going to place the tail of the arrow on 0. We always start at 0. Draw the arrow 2 units to the left at 0 and stop at negative 2. So that is going to be our beginning, right? So we are going to add negative 2 and 3. So let's just go ahead and do it on the number line, and then we will record the steps. We will start at 0, and now we are drawing in the arrow 2 units to the left of the 0 and stop at negative 2. So left of the 0, straight arrow, that is called a vector. Okay, just like that. The direction of the arrow is to the left because we are counting down. Left. Now start the next arrow at the end of the first arrow. So where's the end of the first arrow? Is negative 2. That's when we are going to start. Negative 2. Now we are going to draw the second arrow 3 units to the right, since we are adding 3 to negative 2. We are going 3 units to the right. 1, 2, 3. 3 units to the right. and we will stop at 1. We will circle the number at which the second arrow ends and indicate this ending value. Okay, so that's how we add using vectors. Using vectors saves you a lot of time. You don't have to skip all the time. It's just you're drawing a straight arrow, and you can see how bigger or how smaller those arrows are. Okay, it will be just easier for you. Okay, let's move on. Repeat the process from parts A through F for the expression 3 plus negative 2. So now we are going to do a different problem, 3 plus negative 2, using the number line. You can look at the steps if you want, you don't have to. We always start at 0. Always start at 0. My first arrow is going to go from 0, 3 units to the right, and we will stop at 3. My second arrow will start at 3, that's where I ended, and it will go 2 units to the left since I have negative 2 here, 2 units to the left, and I will stop at 1. What can you say about the sum of negative 2 plus 3 and 3 plus negative 2? So if I look back at my other drawing here, how to make it, let's see, I'll make it easier if I just put one below the other. Okay, so this was negative 2 plus 3, and this one is 3 plus negative 2. How are they the same and how are they different? Is 3 plus negative 2 and negative 2 plus 3 give us the same answer? Yes, they do, right? So are they the same? Yes, they are the same. What is their difference? Difference is that we have switched the numbers around and our arrows are pointing to different places, but initially we are getting the same answer, right? We're just switching the numbers. Okay, so what can you say about the sum of negative 2 plus 3 and 3 plus negative 2? The sum is the same. The sum is the same. We have the sum is 1. Does the order matter when we add numbers? One was negative 2 plus 3, the other was 3 plus negative 2. The numbers are in different order. So the order doesn't matter because the sum is the same. The order doesn't matter because the sum is the same. Okay. Think about addition problems. 2 plus 3 equals 5. Can I do 3 plus 2 equals 5? Absolutely. So what rules works for addition of only positive numbers that you knew until now? It also works for integers. You can also add integers, positive and negative integers, in different order and still get the same answer. Okay? Expressing absolute value as the length of an arrow on the number line. Okay, so remember absolute value. I told you to remember that term. That's where it is. Absolute value is the distance from 0 to the number on the number line. You just need to remember it's the distance. The distance is always positive. Okay, so how does absolute value determine the arrow length for negative 2? Use the number line to support your answer. Okay, so let's draw that negative 2 on the number line again. So start at 0 and move 2 spaces to the left. So how does absolute value determine the arrow length for negative 2? Absolute value of negative 2 is the distance from 0 to negative 2 on the number line. That's what it is. And that distance is 2 units. Is my arrow 2 units long? Yes. So you can say that the length of an arrow is the absolute value. The length of an arrow is the absolute value. So just by looking at how long my arrow is, I can say the absolute value of my number. Okay? And that is 2, right here. How does absolute value determine the arrow length for 3? Use the number line to support your answer. So if I go from 0 to 3, the absolute value of 3 is that distance from 0 to 3, which is 3 units. My arrow is 3 units long. 3 units. So I can say that the length of an arrow is the absolute value of 3. The length of the arrow is the absolute value of 3, which is 3. Okay? Describe how the absolute value helps you represent -10 on the number line. How would I represent -10 on the number line? I would draw an arrow or a vector from 0 to -10 going 10 units to the left. So my arrow is going to be 10 units long, right? The absolute value of -10 is going to be 10. Okay? Absolute value represent -10. So -10 is 10 units to the left of 0. So 10 is the absolute value of -10. Okay. So from here we see that the arrow shows the length, right? It doesn't matter to which direction we go. The arrow shows the length. It shows the distance. Yes, it's in different directions, but the arrow still has that distance. It's still long. So the absolute value of -10 will be 10. The absolute value of 3 is 3. The absolute value of -2 is 2. Those arrows have the length, therefore the absolute value is always positive. Okay. Exercise 2. Model each of the expressions on the number line provided. We need to show -6 plus 4. To show -6 plus 4, we are going to start at 0 and go 6 units to the left because we are going at -6, and that's where we are going to stop. What is the absolute value of -6 in this case? 6 units, right? 6. And we are adding 4 to the -6, so now we are starting at -6 and we are going 4 units to the right because 4 is a positive number. And after we go 4 units to the right, we end up at -2. -6 plus 4 is -2. Okay, absolute value of 4 in this case is 4. 3 plus -8. I start at 0 and I go 3 units to the right. Absolute value of 3 is 3. I'm adding -8 to the 3. I'm going 8 units to the left from where I stopped at 3. So 3 and then 5 more, and I would end up at -5. I went 8 units. Absolute value of -8 is 8. Okay, so I went to 3 and then 8 units to the left. Okay. Oh, and here we need to write the answer, -5. All right. Finding sums of a number line model. So here the same thing, we just need to make sure we understand everything. Find the sum of the integers represented in the diagram below. Okay, the integers. So we're just looking at the integers here. We're looking at 5 plus negative 2 plus 3. What is the sum of these three integers? Is 6. So write an equation to express the sum. My equation will be, I started at 5 plus negative 2 plus 3. 5 plus negative 2 plus 3 equals 6. What three cards are represented in this model? So if I were to use cards, integer cards, my cards would be 5, negative 2, and 3. In what ways does this model differ from the ones we used in lesson 1? Remember how in lesson 1 we were skipping? We would draw a number line and we would skip count 1, 2, 3, 4, and so forth, right? Now we are not skipping anymore. The skipping part is over. Now we are using vectors, right? We use vectors. What connection can you make between the sum of 6 and where the third arrow ends on the number line? The third arrow ends on the sum. The third arrow ends on the sum. That's their relationship. Would the sum change if we change the order of the addends? Or would the diagram change? Let's take a look. So if I were to draw this number line again, and that's 0, and let's just change these three numbers around. Let's say I want to start 3 plus 5 plus negative 2. Would it be same or would it be different? I just changed the numbers around, right? I changed the order. So let's see. I will go 1, 2, 3. So that's my first arrow. 1, 2, 3, 4, 5. So 4, 5, 6, 7, 8. I would add 5 to my 3 and I would stop at 8. My last stop would be I will start at 8 and I will go 2 units to the left and I will end up at 6. Okay, so did the sum change if I change the order of my addends? The sum did not change. It was 6 and it is 6 now. So the sum doesn't change. The sum doesn't change. But does the diagram change? The diagram does change because right now the arrows are going different ways, right? The diagram did change. Diagram changes. Okay, the arrows are going to different places if you want to clarify that. Okay, so this is it for this lesson 2. If you have any questions, please let me know. Otherwise, what you need to remember is that when we add integers, you would add them on the number line using vectors. And when we add a negative number, we go to the left of the number line. When we add a positive number, we go to the right of the number line. It's like going up and down on the vertical number line. Down is for negative numbers, up is for positive numbers. The sum of the two integers doesn't change if the order of those integers changes. So that's another thing that you need to remember. Good luck, and I will talk to you later.